Stacked images from Punch showed the interstellar object, 3I Atlas, sweeping past the sun, but something was wrong. The data didn't match predictions. Its motion defied pure gravity. The radial acceleration, directly away from the sun, measured 135 km per day, and the transverse component about 60 km per day too. That might sound small, but over weeks it compounded. In just 30 days, Low calculated, non-gravitational forces had shifted 3I Atlas by nearly 80,000 kilometers, enough to throw its orbit wildly off course. In celestial mechanics, that's catastrophic. The difference between a comet showing up on time and one vanishing into the void. On October 29-30, 2025, 3I Atlas reached perihelion at 1.36 AU, just outside Earth's orbit. Close enough for solar heat to matter. Close enough for ice and volatile gases to sublimate. But unlike any known comet, it showed no visible outgassing. No coma, no tail, no emission lines. Yet the acceleration persisted. Photometric studies revealed an unnaturally steep brightening, brightness increasing with distance to the power of 7.5, far steeper than the 2 to 4 typical of comets. And while JWST detected early traces of CO2, the expected surge of water vapor near perihelion never came. The evidence, motion, brightness, composition, pointed toward one conclusion: something unusual was happening. Whether that meant our models were flawed or that 3I Atlas wasn't a comet at all remained the burning question. Avi Low and his peers split into camps. One side saw an exotic comet. The other, something engineered, a light sail or interstellar probe. If the acceleration were due to venting gases, the mass loss should have been visible. It wasn't. If it were radiation pressure, then Atlas might be thin, reflective, constructed. And the color anomaly, a faint, unnatural blue hue, deepened the mystery. The upcoming observations, scheduled for November and December 2025, would decide the matter. Either Atlas would reveal itself as a volatile-rich comet or as something that should not exist. When November came, the telescopes turned. JUICE, still months from Jupiter, swung its instruments toward the drifting enigma. Spectrometers hummed, data flowed, and then nothing. No clear CO2 spikes, no water vapor. The readings came back colder than expected, quieter than background radiation. It wasn't emitting like a comet, it was reflecting. A surface model fit best if Atlas was smooth, almost mirror-like, and tumbling slowly. The light curves suggested panels or facets, geometry inconsistent with natural fragmentation. But the data was ambiguous, open to interpretation. At NASA's Jet Propulsion Laboratory, analysts argued deep into the night. Some whispered artificial, others rolled their eyes. When the first raw JUICE images leaked online, faint glimmers, like a diamond spinning in sunlight, the world lost its collective breath. December brought clarity, or confusion disguised as data. Hubble saw no dust trail. JWST found faint thermal signatures, arranged in a grid pattern. Too regular, some said. The team at Goddard flagged a reflection periodicity. Every 47 seconds, the brightness peaked, as though a rotating plane were catching sunlight. Low went public again, his voice measured but urgent. If this is natural, then nature is far more inventive than we imagined. NASA refused to comment on the pattern. Online speculation boiled: a derelict probe, a solar sail, a monument adrift for millennia. Governments convened quietly. SETI expanded its listening schedule, sweeping the frequency range around Atlas's coordinates. For the first time, the signal-to-noise ratio dipped below the threshold. Almost something. By January 2026, Atlas was retreating from the sun, fading, but not fading evenly. Its light dimmed in pulses, rhythmic and deliberate. A graduate student in Seoul noticed first. The intervals weren't random. They formed a prime number sequence. The world erupted. Was it a coincidence, a trick of rotation, or a message written in photons across the void? Every telescope turned toward the dying glimmer of 3I Atlas. In its final weeks of visibility, the pattern repeated 3 more times. Then, abruptly, it stopped, like a heartbeat ceasing mid-sentence. And in the silence that followed, humanity realized that for the first time, the universe might have spoken. The primes were a key, not a message. That was the consensus after a feverish week in which half the world tried to decode meaning out of silence. The intervals, 2, 3, 5, 7, 11, repeated in triplets, then ceased, as if 3i Atlas had tapped politely on the door and waited. When nothing answered, it powered down whatever mechanism had choreographed the pulses and fell back into its austere glide. At the SETI array in the Karoo, a junior systems engineer named Zoya ran a reckless experiment. She pointed a narrow-beam laser at a calibration satellite and modulated its reflection in primes, then in binary blocks of 1024 bits, spaced at the same cadence Atlas had used. It was theater. Nothing could reach Atlas across tens of millions of kilometers at that power, but it clarified something subtle. The cadence wasn't just counting, it was framing. The primes carved time into slots, like a transport layer, the network folks said, a handshake. Hubble's final week of usable viewing added a complication. The specular spikes, those knife-edge flashes when a facet aligned with the sun, weren't perfectly periodic. They drifted by microseconds per hour, a tiny, graceful slip. Natural precession could do that, but the drift matched the derivative of solar flux at Atlas's changing distance. Someone had written a feedback loop into the sky. In Geneva, the International Asteroid Warning Network convened a hasty plenary. The agenda title was Milk a Toast, coordinated observations of unusual hyperbolic object, but the subtext was electric. Two motions emerged. Treat the prime sequence as a link layer probe, a standardized test to discover whether a listener can segment time the same way. Attempt a reply not with radio or laser, but with light curve, the only channel Atlas had demonstrably used. Turn a spacecraft into a mirror, a French optical physicist said, or a shutter. Or use what we already have, Zoya countered, dialing into the plenary from a cafeteria. Only thing bright enough in the right band is the sun. Modulate reflection near the sun, and it will see us. No one liked the phrase near the sun, but they liked the math, the Oberth effect, the leverage you get by changing velocity at the bottom of a gravity well. If you could throw a small steerable sail into a deep solar dive and flicker it at the right cadence as it climbed back out, Atlas might see the flashes as deliberate structure riding on sunlight. By midnight, the idea had a name, Quiet Protocol. No claims, no declarations of sentience, just a reply in kind, primes, then an empty frame inviting content. The first rule of interstellar conversation, written on a whiteboard in block letters, was simple. Answer softly. While committees debated, the public moved faster. Amateur astronomers across 3 continents synchronized shutters on backyard rigs and, absurdly, pulsed at the night. The signals went nowhere, absorbed by air and clouds and human longing. But in their clumsy mimicry, a consensus formed. If the universe had knocked, someone should at least open the latch. Atlas, indifferent, faded along its hyperbolic path like a cathedral drifting through fog. You can't build a flagship in months, but you can build a fast, small, throwaway miracle. The mission took shape in a repurposed clean room near Turin. Engineers rated catalogs and flight heritage spares, then machined the rest from foils and lattice. The bus was skeletal, just enough structure to hold reaction wheels, star trackers, and a compact cold gas system. The payload was audaciously simple, a 2-stage solar sail, inner layer specular, outer layer slightly absorptive, each panel able to cant a few degrees on MEMS hinges. A mirror with attitude. They called it Saffron because someone spilled saffron tea on the first flight blanket and the name stuck. Trajectory design was a knife fight with time. Saffron would launch on a rideshare to a high-energy escape, perform a solar Oberth skim to 0.25 AU, then bloom its sail at perihelion. There, in the white roar of sunlight, it would flash, on-off shutters and prime cadences, its signal modulating the sun itself like a glinting Morse. Window, cadence, link budget, thermal limits. Every parameter was a cliff edge. At 0.25 AU, sunlight is 16 times stronger than at Earth. The sail had to survive long enough to blink, then fold, then survive again. Zoya joined guidance and control. Her code ran in a sandbox first, then on brass board, then on the flight computer with the safeties off. She didn't look up when a diplomat toured the lab. She looked up only when the simulation showed the worst case. The sail overshooting perihelion by 2 seconds and tearing itself into lace. 2 seconds is the mission, she said. The world watched because there was nothing else to do. In living rooms, in classrooms, in hospital wards, the launch streamed on 1,000 tiny screens. The booster Saffron drifted free like a seed. En route, the little craft practiced, micro-flashes against the black, calibrating its hinges, learning its own jitter. The star tracker grew superstitious about bright giants. Zoya taught it to ignore old gods. At last, Saffron fell toward the sun. Telemetry thickened with heat events and tiny corrections, a ballet of panic. The sail unfurled into geometry and fire. At perihelion minus 30 seconds, the shutter pattern armed. At minus 10, it began. 2, 3, 5, 7, 11. Slots carved from light. Then an empty frame, an offer.